Good evening and welcome to this machine programming presentation by Ezequiel Ramirez and Colin Morris-Moncada. So what is machine programming? Machine programming is when any system delivers a significant degree of automation to reduce the cost of producing secure, correct, and efficient software. This is taken from the source of the 3 pillars of machine programming with the Justin Gottschalk. Such systems will also enable non-programmers to tackle real-world problems, having to code only as much as is necessary for their needs. So what is machine programming? What it is automating development and maintenance of the software, creating systems that make their own software, or in other words, software that creates software, using patterns and data to make predictions about what to do next in a program. Current programmers would spend less time debugging software, ideally. It's also a way to enable more people to program. Many entrepreneurs would have greater ease of access to software-assisted goals. So what is machine programming not? It is not the end of jobs in America, and it is also not omniscient or all-knowing. It's a very interdisciplinary approach, requiring the intersection of multiple fields, and it brings all those fields together. History of machine programming. So the idea of machine programming or automating software has always been present. However, due to many factors in our globalized world, it's now becoming harder to keep up with the constantly evolving surroundings. The common approach or status quo of the past is not sufficient to solve our current problems. Intel and MIT are changing the way humans look at programming. The definition of machine programming is now starting to expand to be more inclusive of other careers that otherwise might not have intersected with programming at all. In 2018, Intel and MIT released their paper titled 3 Pillars of Machine Programming, and those pillars are invention, intention, and adaptation. Invention emphasizes the creation or refinement of algorithms or core hardware and software building blocks through machine learning. Intention emphasizes advancements in the human to computer and computer to machine learning interfaces, and adaptation emphasizes advances in the use of machine learning based constructs to autonomously evolve software. Those are the abstract definitions of the 3 pillars. So this paper intends to be a foundational starting point to expand on the idea of machine programming. So applications. It's most used for dealing with data or complex problems in the real world that utilize machine learning or deep learning techniques. So gathering intent from a user and easily translating that into a working solution is the primary application. Examples of future applications are listed here, and I used GIS or Geographic Information Systems as an example where large amounts of data points and thorough statistical analysis can provide models driven by these statistical insights. So there's no telling what the impact machine learning can have for companies such as ESRI. Machine learning is already being implemented, but machine programming in conjunction with machine learning could have limitless possibilities. So in fields such as anthropology and archaeology, machine learning is also being implemented to solve complex questions relating to cultures across our planet. And then other examples include big companies utilizing machine programming in the next 5 to 10 years, such as Facebook, Google, YouTube, and Baidu. So all these are examples of future applications that could take advantage of machine programming. So who's involved? Well, Intel Labs and MIT are involved, and then these are the individuals, a couple of the individuals on the paper of the 3 Pillars of Machine Programming paper, and their contributions have allowed other engineers to look towards a future where automation is a force for good and it can bring multiple disciplines together. So here are some of our sources. So these are some sources for real projects. These are technology related to deep learning. And these are just some Google searches of machine intelligence, machine learning, and the difference between machine learning and programming, or the Quora article. And my resources were, I had just put some of the stuff I talked about earlier in the slides. So I have an Esri article about machine learning and how it's used in their GIS platform. And then I had an article, an IEEE article about video games and machine learning in video games and deep learning. And I thought this was relevant because of Facebook rebranding their corporation as Meta. And then I used the example of an archaeologist that used machine learning and enhanced. I'm saying it would be enhanced with machine programming techniques. Yes. So this was an example of them using machine learning, but pointing that it could be enhanced with machine programming techniques. So the research paper that we used was from the 3 Pillars of Machine Programming, and it was one of the sources. So they used it as an example of in their paper. So what is it? So it's verified lifting of stencil computations. So that is the taking an imperative language and they translate it into a domain-specific language without losing the meaning or results of the starting code. So being able to translate from the imperative to the DSL. So they solved the problem by using syntactic restrictions, inductive template generation, and the use of skolemization and partial skolemization in their compiler, which they called STNG. So it relates to machine programming because it combines all aspects of the 3 pillars of machine programming, which is invention, intention, and adaptation. The key results were being able to use a novel lifting stencil computation technique in place of a traditional syntax-based technique. This presents an application of using machine programming to solve a problem. Software development would fundamentally change if machine programming was to be available in the near future. GitHub Copilot is an example of how humans have solved many of the common programming problems that there is, and each solution could further be categorized into how efficient it is or when a user should implement one solution over the other, and that could be implemented in a machine programming technique. It becomes a problem of how to create that foundational system that can be shown to be used globally so machine programming can truly live up to its potential and not be twisted by companies and people with nefarious motives. Hardware development. So as Moore's law and the Dennard scaling effect see their demise, the next steps in hardware development become increasingly important. So there are many emerging technologies, and I'd like to name a few, which are quantum computing and graphene-based transistors, which would be beneficial for machine programming because it would allow humans to solve problems at rates we have not seen before. So quantum computing and graphene-based transistors are technologies that are being researched currently that differ from our current computing paradigm. And this would be a paradigm shift in how we look at computers and how they're made and how they interact with software. And then I use the field of GIS, or Geographic Information Systems. And I use this because the biggest existential problem in the 21st century will be climate change and how countries react or do not react to this growing threat. So climate models require much data, and machine learning is very beneficial in the statistical analysis done every day with GIS software. The future of GIS powered by machine programming could mean that solutions for city councils, states, and the federal government could be accelerated, making the switch to a cleaner future more tangible. I understand that a lot of people don't feel that climate change is tangible, like it's just not worth it to invest in cleaner energies, but machine programming would allow us to tangibly reach the goals that are required of us. And I think that's the end of the presentation. I hope you enjoyed, and I hope that it was very informative. Thank you.